In this video, I'm going to show you some ways that we can work with classified raster data and how we can summarize the data from the rasters and integrate it into a polygon data set. So in this example, we are seeing the Upper James sub-basin within Virginia, and the smaller boundaries you can see in here, those delineate the 12-digit hydrologic units. That's these HU12 boundaries. And the raster data I'm using is from the MRLC. It's NLCD land cover from 2023. This is a classified data set, so we can actually open up the attribute table and see it. And the values are numbers that represent a type of land cover. So they don't, you can't think of 11 as the number of 11. It's really just a code for the open water class, just like the number 21 represents the code for developed open space. So you can see what each of these numbers means from this legend. And the count, that's telling you how many pixels are in that particular class. So in code 11, which is open water, you can see that there's 22,483 pixels in this data set. So what I want to do here is I actually want to determine what land covers are present and in what amounts within each hydrologic unit. So to do that, I need to use the Tabulate Area tool. So the zone data is coming from these HUC12 boundaries. The zone field I want to use, let's look at that table for a minute. I want a unique ID that's going to identify those polygons. I'm going to use this HUC12 identifier. That's the 12-digit code for each hydrologic unit. And then the raster that I want to summarize is that land cover data. The class field is the value. And for the output table, let's call that HUC12 land cover. And we're going to go ahead and run that. So that's generated this standalone table here. Let's open it up and see it. So you can see that HUC12 field, that's the unique identifier for each hydrologic unit. Again, that is coming from this table. It's coming from the HUC12 field. So that's identical to this. As you can see, there's 60 records in each. So basically, there's going to be a record for every single hydrologic unit in that feature class. And then you have these fields called value underscore and then a number. And so value underscore 11, that's referring to the open water class. Value underscore 21, that's referring to the developed open space class, etc. through all these different types, all the way through value underscore 95, which is the emergent herbaceous wetlands. And then the numbers that you see here, those are the number of pixels of that land cover class within that HUC12 unit. So here we can see in the HUC12 that's identified by this code, it's got 9,000 pixels of open water, a huge number of pixels of developed open space, etc., etc. So you can see the number of pixels of each type of land cover within that HUC12 boundary. Now, if we want to attach this information from the table back to the polygons, then we can use add join, or if we only want to attach a couple of specific fields, we could use the join field tool, but let's go ahead and use the add join tool. So the input table is the table that's going to receive the data. That's going to be HU12 boundaries. And then the land cover is going to be attached to it. The land cover summary table here, that standalone table. And then the fields that are going to join it, we're joining it based on that HUC12 attribute. You can validate the join. You can see that there's 60 records that are matched. That's what we want. And so we can run that join. And then, of course, you can see all those fields have been appended. Now I'm going to go back and I'm going to go ahead and remove that join because we don't really need it right now. I'm going to do something else, but I just wanted to show you how you could do that. So I'm going to remove the join. And now we're back to what we originally had in that table. So what I want to do instead here is I actually want to make this table a little more informative because it's hard for me, unless I've memorized every single code, it's hard for me to tell. Like I have to keep referring back to the legend to see what is value 41. Okay, that's deciduous forest. And personally, I actually know most of the codes by heart because I've used them so long, but maybe you haven't. And so you'd rather have these fields named differently. So I'm going to show you a trick using the alter field tool. This is going to rename the fields, and this will make it a little easier. So my input table is again the standalone table that we just created. And the first field name that I want to change is the value 11 one. I'm going to give it a new field name. I'm going to call it open water. And I want to give the alias the same name. I hit run. Okay, so now you can see that value underscore 11 field has been replaced by a field called open water, and that just makes it a little easier to understand the table. So I'm not going to show you this for every single field. I'm just going to come back after I've done it, and then we'll continue from there. Okay, I'm back. I have run that alter field tool multiple times, and now you can see all my field names have been changed to something that are easier to understand. And now I would like to determine what percentage of each hydrologic unit is in agriculture. And there's two agricultural classes. There's code 81 for pasture hay and 82 for cultivated crops. So I'm going to determine the percentage of those types in each hydrologic unit. So for that I need the calculate field tool. So my input table again is this standalone HUC12 land cover table. I can either put this in an existing field, which I generally don't want to do, or I can create a new field. So I'm going to create a new field and I'm going to call it perc ag for percent agriculture. And I need to make sure I change the field type to a numeric type. And I'm going to make that a double. And now I have to put in an expression. So first I need to put in, so basically I'm going to have the agricultural types in parentheses divided by all land cover types, and I need sums within both of those parentheses. So I'm going to click inside the first parentheses and I'm going to double click the field I want, which is pasture. Notice how it's added these exclamation points on either side. That's Python code telling it that it's a data field. So I want pasture plus crops. Oops, not there. I want crops there. So the numerator is pasture plus crops. And then I need the sum of all the land cover types in the denominator. So I'm going to just add each one of these in terms. Intern. Open water plus open space plus low intensity plus. Okay, now I have added all those types in the denominator. My parenthesis thing got in the wrong place, so I'm going to move that and put that at the end. Now, right now, as it stands, I'm going to get a proportion, but I actually want it as a percentage, so I'm just going to multiply the whole thing by 100. And hopefully I have that formula right. And here, I think it's good to enable undo. So if you screwed up your formula somehow or it doesn't work, you can always undo it. If you don't do this, then you run it and it's permanent. Okay, so I'm going to run. Now I can check that field at the end. There it is. It's giving me percent agriculture. And that looks good. I'm going to go, I have to go up to this edit tab and then hit save. And so now it's permanently saving that new field. So let's see what this looks like. Now I can actually, now I want to add this percent agriculture. I want this field added to my boundaries. So now I'm going to use join field. So the recipient table is going to be those HUC 12 boundaries. The join table is going to be that standalone table with the land cover summaries. The key field to join those two is going to be the HUC 12 code. And then the field I want to transfer is that last one that I created, which was percent agriculture. Can validate the join. You can see it's matched the 60 records. We're good to go, and run it. Close these tables for a second. Okay, so now we look at the HUC 12 boundaries, and there it is. Now just look at the land cover for a minute. You can see that there's a lot of agriculture down here and some up here. So I'm going to re-symbolize the boundaries based on the percent agriculture. So hopefully you'll see the same general pattern here. Instead of single symbol, we're going to do graduated colors. Let's choose a different scheme. And this is going to be by percent agriculture. And we'll do quantiles. Okay, so you can see these are the hydrologic units with the most agriculture in dark brown. All right, success. Now I'm going to show you another way that we could have actually achieved basically the same objective. So this time, let's reclassify this land cover raster so that anything that's agriculture gets a value of 1, and anything that is anything other than agriculture gets a value of 0. So for that, we need the Reclassify tool. So we'll use that land cover raster. We've got the unique values shown here. And so I'm going to put a 0 everywhere. And this is a little tedious, but I just have to go through and type the 0. So this is the old value, and it's going to be converted to a new value. I'm just going through, call everything 0 until I get the 2 agricultural classes, which are 81 and 82. I'm going to make those 1. Oops. 1. So 81 and 82 get the values 1, and everything else gets a 0. And we'll call this, let's just call this reclass ag. And So now this is going to output a new raster. And I could re-symbolize this. Let's just make 0 gray, and this will be like that. And we can relabel it. So non-agriculture and agriculture. All right, so that's our new reclassified raster. And then we could use this raster and we could summarize by these same Huck boundaries. All right, I am going to actually create a copy of this layer. I'm going to right-click, copy, paste. I've got 2 copies of this data. This one I want re-symbolized back to just plain single symbol there with the boundaries. And I'm going to rename this one just so we know what we're doing. This is going to be from the reclass and zonal stats. And I'll get to that in a minute. And this one I'm going to call rename and just say, because this one was done using the tabulate area method. Okay, so we'll just see what these look like. Okay, so I'm going to replicate what I just did, but using a different matter. So we just reclassified, and now I'm going to use zonal statistics to get the mean or the percent agriculture within each zone, which is delineated by these watershed boundaries. So let's go to the zonal stats tool. We're going to go to zonal statistics as table. So again, our zone data is defined by those Huck 12 boundaries. We'll use this one this time. And we want that Huck 12 ID. The value raster this time is going to be the reclassified raster showing agriculture. And we'll do output table. We'll call it, let's just call that Huck 12 ag. And let's just get the mean. So it's basically taking the average of a bunch of zeros and ones. So you're going to get, and that essentially comes up with the proportion instead of the percentage. You'll just get the proportion of agriculture. So let's look at this table. So now you can see for each Huck 12, this is the mean, and essentially the mean is proportion of agriculture. If we want to turn that into a percentage, we can always use that calculate field again, but honestly, I'm fine with just having it as a proportion. However, I would like to rename that field just for clarity. So let's use that alter field tool again. Nope, not that one. I want the Huck 12 egg. And we're going to rename this field mean. We're going to rename it to prop ag. So that's proportion of agriculture. Okay. And now we can use the join field tool again. So again, the recipient table, that's going to be this one. Huck 12 is our ID. The join table is going to be this Huck 12 ag. Same join field. And we want to transfer that proportion agriculture to it. And run. So, oops. I'm going to turn off this feature class, and now I'm going to re-symbolize this one with graduated colors based on the proportion agriculture. And I'm going to use that same color scheme. So look how that layer looks. I'm going to turn on the other layer. Oh, and they need to be quantiles so that they'll both look the same. Okay, so in theory, these two layers should look the same. So I'm going to turn this off, and then you can see the other one, and you'll see it's exactly the same. So I got the exact same result in two different ways.